Dear students, this is Nilanjana Sanyal from onlinemathtutor.me and ePodashuna. Today we will be learning how to find the square root of a decimal number by the long division method. In our last session, we had learned how to find the square root of a whole number by the long division method. And in this session, we will be learning how to find the square root of a decimal number by the long division method. So let's start. Now we have to find the square root of this number by the long division method. And these are the rules that have to be followed in order to find the square root of any decimal number by the long division method. And over here it is assumed that all the digits lie on the right hand side of the decimal point. We are having only this number 0 on the left hand side of the decimal point. These rules assume that there is only a single 0, or you may have a number of zeros, hardly matters, on the left hand side of the decimal point. So first rule says that count the number of digits. First of all, let me write the number. It is 0.000361. Count the number of digits after the decimal point. 1, 2, 3, 4, 5, 6. This is the decimal point. So after the decimal point, we are starting our counting. 1, 2, 3, 4, 5, 6. There are 6 digits. Add extra zeros at the right end of the number if the number of decimal digits is odd. But we are having even number of decimal digits, so we do not have to add any extra zeros. Or if the required number of decimal places in the square root demands that. Now, this portion is necessary if the given number is not a perfect square. Let us see whether this is a perfect square or not. Coming to rule number 2. Place a bar and pair the digits starting from the digit next to the decimal point. This is the decimal point, so we will be starting with this digit and we will be pairing the numbers. So this is the first pair consisting of 2 zeros, next 0 and 3, and the third pair is 6 and 1. We are putting bars on top of each pair of numbers. Rule number 3. Find the largest number whose square is less than or equal to the digits under the leftmost bar. The leftmost bar is containing the two digits 0 and 0. First of all, let me put this sign. So 0 and 0, and we have to find the largest number whose square is less than or equal to the digits under the leftmost bar. Obviously 0 square is 0, so we will be writing and write the largest number in the divisor place. This is the divisor place, so we will be writing 0 over here. And since all the digits are after the decimal point, therefore in the quotient we will be putting 0 point. This is the largest number which when squared will be giving us a product which will be equal to a 0. Write the largest number in the divisor place. We have written that. And as the first digit of the quotient. So we write 0 over here as well. We are writing the quotient at the top after the decimal point. So we have put the decimal point. And then we have written the 0 after the decimal point. Write the square of that largest number beneath the original number under the leftmost bar. The square of 0 is obviously 0. So we can write a single 0 or we can write double 0, doesn't matter. Perform a subtraction of the two numbers. So we will be performing a subtraction. Obviously this is 0. So I do not want to bring down this 0. Rule number 5 says bring down the next two digits together. the next two digits are 0 and 3. So we are bringing down 0 and 3. And write them beside the result of the subtraction. Since the result of the subtraction is 0, I haven't written that. If you have any number other than 0, then obviously you will be having that number over here. Now we have brought down 0 and 3. Together they now form a single number. 0 and 3 is practically nothing but a single 3, which becomes the next dividend. So 3 is our next dividend. Rule number 6. Double the quotient obtained so far. The quotient obtained so far is 0. So if we double this 0, 0 multiplied by 2 will be giving us a 0. And write it in the divisor position. So we have to write a 0 over here. This is the divisor position. This is the dividend. Let us call it as D. So D is equal to 0. Rule number 7. Write a number S besides D. It should be on the right hand side, such that the whole divisor becomes equal to DS. This is D and this will be S. Add S as the next digit of the quotient. We have to, whatever we write over here, that is S, we have to write S over here as well. It will be the next digit of the final quotient. The number S should be chosen in such a manner such that the multiplication of the number DS by S yields a product less than or equal to our present dividend. Our present dividend is 3. Now we have to add a number over here, which when multiplied by itself will be giving us a product which should be equal to either equal to 3 or less than 3. If we put a 1 when multiplied by 1 will be giving us a product of 1 which is less than 3. If we write 2 multiplied by 2 will be giving us a 4 which is greater than 3. We cannot have a number which will be giving us a product greater than the current dividend. So the number that we will be putting over here is 1. S is equal to 1, and since we have put 1 over here, S is equal to 1. We have to put a 1 over here as well as the next digit of the quotient. Write the product beneath the dividend and perform the subtraction. So 1 multiplied by 1 will be giving us a product of 1 and subtraction 3 minus 1 is 2. Rule number 9. Repeat steps 5 to 8 till the remainder becomes equal to 0, or you get the square root with the required number of decimal places. Now this will be required when the number given to us is not a perfect square. For this number, let us see whether it is a perfect square or not. So repeat steps 5 to 8 till the remainder becomes equal to 0. And what is 5? Bring down the next two digits together and write them beside the result of the subtraction. So we bring down these two digits 6 and 1 and we write them beside this 2. Together they form a single number. It is 261, which becomes the next dividend. Rule number 6. Double the quotient obtained so far. The quotient obtained so far is 1. Doubling 1, we get a 2 and write it in the divisor position. Since this is the dividend, the divisor position will be over here and we will be writing 2. Let us call it as D equal to 2 in this case, and we have to put another number over here. That will be our S. Rule number 7. Write a number S besides D such that the whole divisor becomes equal to DS. Add S as the next digit of the quotient. We have to add S over here as well. The number S should be chosen in such a manner such that the multiplication of the number DS by S yields a product less than or equal to our present dividend. Now this is our present dividend, 261. We have to put a number or a digit over here and we have to multiply this entire number consisting of 2 digits by that number or that digit or s. So first of all, let me draw a rougher column. What can we take? So let us start from 5. If the number is 5, then we have to multiply this 25 with 5. And 25 multiplied with 5 will be giving us a product of 125, which is smaller than 261. Let us try a larger number, larger than 5. Let us try 27. It is 7 times 7 is 49. 7 times 2 is 14 plus 4 is 18. Again smaller. Let us try 9. 9 times 9 is 1 and 8 over here it is 81. So 9 times 2 is 18 plus 8 is 26. So we are getting 261. Perfect. So we put a 9 over here and a 9 over here as well. Write the product beneath the dividend and perform the subtraction. So the product 29 multiplied with 9 is 261 and perform the subtraction. It is a 0. Rule number 9. Repeat steps 5 to 8 till the remainder becomes equal to 0. Or we are not going to OR part because the remainder has become equal to 0. So we stop. Rule number 10. The final quotient is the required square root. So the required square root is 0.019. Let us write the answer. Square root of 0.000361 is equal to 0.019. This becomes our answer. So this is how we perform the long division for finding the square root of a decimal number. Let us take up another sum which is not a perfect square, where we will be dealing with a number which is not a perfect square. Now these are the same set of rules that we have seen before. And now the question is, find the square root of 0.438 correct to 2 decimal places. Since it is not a perfect square, we have to find the square root of this number correct to 2 decimal places. So first of all, let us write the number. This is the number. Now coming to rule number 1. Count the number of digits after the decimal point. Add extra zeros at the right end of the number if the number of decimal digits is odd. Now, how many digits are we having after the decimal point? 1, 2, and 3. So the number of decimal digits after the decimal point is odd. So we have to add an extra 0 in order to make it an even number. Now we are having 4 decimal digits after the decimal point. I'll be coming to this part if the required number of decimal places in the square root demands that afterwards. Rule number 2 says, place a bar and pair the digits starting from the digit next to the decimal point. Therefore, we will be pairing these 2 and these 2. Rule number 3. Find the largest number whose square is less than or equal to the digits under the leftmost bar. The digits under the leftmost bar are 4 and 3. Let me put this sign. Find the largest number whose square is less than or equal to the digits under the leftmost bar. So less than or equal to 43. 4 and 3 are the digits under the leftmost bar, and write that largest number in the divisor place, that is over here, and as the first digit of the quotient after the decimal point. So we have to, whatever we add will be after the decimal point, so we can safely put a 0 point over here in the quotient place. Now we have to find the largest number, which when squared will be giving us a product which will be less than 43. 1 squared 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, 6 squared 36, 7 squared 49, which is more than 43. So we have to take 6 squared. Therefore, the largest number will be 6. So we write 6 over here and 6 over here. Write the square of that largest number beneath the original number under the leftmost bar. So 6 squared is 36 and we write 36 below this 43. Rule number 4. Perform a subtraction of the two numbers. So we perform a subtraction. 43 minus 36 is 7. Rule number 5. Bring down the next two digits together and write them beside the result of the subtraction. We bring down 8 and 0 and we write them beside this 7. Together they now form a single number. Now we are having this number as 780, which becomes our next dividend. Rule number 6. Double the quotient obtained so far. The quotient obtained so far is 6, so we will be doubling that. So 6 times 2 is 12 and we will be writing that in the divisor position. Since this is the dividend, this will be the divisor position and I am writing 12 over here. Let us call it as D. So D is equal to 12. Rule number 7 says write a number S besides D. So we will be having a number over here which will be S, such that the whole divisor becomes equal to DS, that is 1, 2 and another number, another digit. Add S as the next digit of the quotient. We have to add S over here as well. The number S should be chosen in such a manner such that the multiplication of the number DS by S yields a product less than or equal to our present dividend. So what will be the next number? Now let me draw the rough work column. Let us take 5. 5 is the middle number, so I often start with 5. Therefore, the whole divisor becomes 125, which should be multiplied with 5. And 125 multiplied by 5 will be giving us 625. 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. 5 times 1 is 5 plus 1 is 6. So the answer, the product is 625, which is smaller than 780. Let us try 6. 126 times 6. It is 6 6 are 36. 6 times 2 is 12 plus 3 is 15. 6 times 1 is 6 plus 1 is 7. So it is 756 and it is less than 780. I think we cannot take 127. 7 times 7 is 49 and 7 times 2 is 14 plus 4, 18. No, it will be 889, which is more than 780. So we have to take 6. And 126 multiplied with 6 will be giving us a product of 756. So we write over here. Write the product beneath the dividend and perform the subtraction. So we have to perform the subtraction. It is 24. There are no more digits left in the number and we have found the square root. But we are having a remainder which is not equal to 0. What do we do to this remainder? And in the question we are having correct to 2 decimal places. In order to get an answer which is correct to 2 decimal places, we have to at least compute 3 decimal places. We have to get a result which gives us the values of 3 decimal places. So we have to get the value of this position as well. How to get the value of this position? For that, we add one pair of extra zeros. Whenever we add zeros, this 0 was a single 0 because this was added to make the number of digits after the decimal point even. But these two are being added in order to get the value of this place. If we have to get a value of any place, we have to add 2 extra zeros. We are adding 2 extra zeros because they can be now paired up. Now this part gets its relevance, or you get the square root with the required number of decimal places. We are having 2 decimal places after the decimal point, but we should be giving the answer correct to 2 decimal places. For that, we require this 3rd decimal place as well. Therefore, we have to go back to rule number 5, which says that bring down the next 2 digits together. The next 2 digits that we have inserted just now for getting this place, the value of this place, we will be bringing them over here. Bring down the next 2 digits together. We have brought down and write them beside the result of the subtraction. We have done that. Together, they form a single number. It is 2400, which becomes the next dividend. Our next dividend is 2400. Rule number 6. Double the quotient obtained so far. The quotient obtained so far is 66. 66 multiplied with 2 will be giving us a product of 132. And write it in the divisor position. This is the divisor position. Let us call it as D. Rule number 7. Write a number S besides D. We will be having a number S over here such that the whole divisor becomes equal to DS. Add S as the next digit of the quotient. We have to add S over here, that we know. The number S should be chosen in such a manner such that the multiplication of the number DS by S yields a product less than or equal to our present dividend. So we have to get a digit over here and we have to multiply this entire number by that digit, and the product obtained should be less than 2400 or equal to 2400. So what can be the number that we can add? If we put a 2, we have to multiply the entire number by 2. That is 1322 multiplied with 2. Let us see. 1322 multiplied with 2. It is 4462. Which is more than 2400. Therefore, we cannot put a 2, we have to put a 1. And we have to put a 1 over here as well. What will be the product? The product will obviously be 1321. And we can perform the subtraction, but we are not interested in performing the subtraction because we have found the value of this position. It is 1. It is less than 5. Therefore, we do not have to add 1 to this 6. So what will be our answer? Let us write our answer. Square root of 0.438 is equal to 0.66 approximately. This is our answer. So now you can understand why did I write you get the square root with the required number of decimal places. And over here as well, you have to add extra zeros if the required number of decimal places in the square root demands that. We have added extra zeros because the square root demands that. The question demands that. We have to find the answer to the correct to the 2 decimal places. Therefore, we had to compute this third place as well, and in order to get the value of this third place, we had to insert 2 more zeros. Now let us try to get a decimal number. Let us try to get the square root of a decimal number which will be having digits on the left hand side as well as on the right hand side of this decimal point. Find the square root of 125.1229 correct to 2 decimal places. The question is suggesting that this is not a perfect square. Now we are not having the rules over here in front of us because I think that we have learned by now how to find the square root of any number by the long division method. So let us try to recall the rules and let us try to find the square root of 125.1229. First of all, we will be writing the number. It is 125.1229. And we will be putting this symbol, this sign. Now comes the pairing part. For this part, always we have to start from the decimal point. We had in the last session, we had said that you start from the ones place. Which one is the ones place? This 5 is in the ones place, which is next to the decimal point. Always you have to start with the number next to the decimal point. And we have to pair. So this is the first pair and this is the isolated digit. And for this part, 1, 2 and 2, 9. So we have paired them. We will be performing the long division right from this side, the leftmost digit, the left out digit. So what will be the largest number which when squared will be equal to or less than this 1? Obviously 1. So we write 1 over here and we write 1 over here as well and write 1 because 1 squared is 1 and perform the subtraction. Since it is a 0, I am not writing a 0. I am bringing down the next 2 digits. They are 2 and 5. Now we have to double this 1. The quotient obtained so far is 1, so we will be doubling this 1 to get a 2. And we have to add one number over here and we will be putting the same number over here as well. That will be the next digit for the final quotient. That will be our S. What can we take as the number? If we take 22, means if S is 2, 22 multiplied with 2 will be giving us a product of 44, which will be more than 25. So we cannot take 2 over here. We have to take 1 because 21 multiplied with 1 will be giving us a product of 21, which is less than 25. And since S is equal to 1, we have to put a 1 over here as well. And we write the product as 21 and perform the subtraction. It is 4. Now we bring down these 2. Since we are bringing down the digits after the decimal point, we have to put the decimal point over here in the final quotient. And we bring down the 2 digits. Now the dividend becomes 412. And the quotient obtained so far is 11, which when doubled will be giving us 22. Now we have to get one number over here, and that will be written over here as well. If we take 2, let us first of all draw this rough work column. So if we take 2 multiplied with 2 is 444, which is greater than 412. So we have to take 1. We put 1 over here. That is 221 multiplied with 1. So the product that we get is 221. And we have to subtract. So the remainder is 191. And we bring down these two. 29. This is 191. 19129 becomes the entire dividend, present dividend. And the quotient obtained so far is 11.1. We will be ignoring this decimal point for the calculation part. So the quotient is 111, 111, which when doubled will be giving us a 222. So we write 222 over here. Now we have to get another digit in this position, and we will be writing the same digit over here. So what can be the number in this position? 222, let us start with 5 because 2225 will be a 4-digit number and we are having a 5-digit over here. So let us start with 5. 2225. 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. 5 times 2 is 10 plus 1, 11. 5 times 2 is 10 plus 1, 11. So it is 11125, which is less than 19129. Let us try 6. 2226 multiplied with 6. 6 times 6 is 36. 6 times 2 is 12 plus 3 is 15. 6 times 2 is 12 plus 1, 13. And 6 times 2 is 12 plus 1, 13. Even this is smaller than the dividend. Let us try 7. 7 times 7 is 49. 7 times 2 is 14 plus 4 is 18. 7 times 2 is 14 plus 1, 15. And 7 times 2 is 14 plus 1, 15. Again smaller than 19129. Taking 8. 8 times 8 is 64. 8 times 2 is 16 plus 6 is 22. 8 times 2 is 16 plus 2 is 18. And 8 times 2 is 16 plus 1, 17. Lesser than the dividend. Let us try 9. 9 times 9 is 81. 9 times 2 is 18 plus 8 is 26. 9 times 2 is 18 plus 2 is 20. And 9 times 2 is 18 plus 2 is 20. This is more than the dividend, so we have to take 8. So our next digit of the quotient becomes equal to 8. And we write the product, which is equal to 17824. And perform the subtraction. This is the remainder 1305, and we have got 2 places after the decimal point, but they have asked us to give the answer correct to 2 decimal places, so we have to get a 3rd decimal place as well, the value of for the 3rd decimal place. For that, what do? We insert 2 more zeros. So we write 2 zeros over here and we pair them. Now we will be bringing down these 2 zeros. The quotient obtained so far is 1118, which when doubled, what do we get? 1118 times 2, 16, 3, 2, 2, 2, 2, 3, 6. And we have to have a number over here which will be written over here as well. So what can be written in this position? It is 2, 2, 3, 6. Let us start with 5. 2, 2, 3, 6, 5 multiplied with 5. 5 times 5 is 25. 5 times 6 is 30 plus 2 is 32. 5 times 3 is 15 plus 3 is 18. 5 times 2 is 10 plus 1, 11. 5 times 2 is 10 plus 1, 11. 6 digit over here also we are having 6 digits. And 111825 is smaller than 130500. Let us try 6. 2, 2, 3, 6, 6. I'm not having enough space, so I have to do the calculation over here. 2, 2, 3, 6, 6 multiplied with 6. 6 times 6 is 36. 6 times 6 is 36 plus 3 is 39. 6 times 3 is 18 plus 3 is 21. 6 times 2 is 12 plus 2 is 14. And 6 times 2 is 12 plus 1, 13. 13419, 6, which is more than 130500. So we can write 5 over here. So we write 5 over here. And 5 comes over here as well. And this part will be 1, 1. This is the thing. 111825. We may do the subtraction, we may not do the subtraction because we have found the 3rd place. So we know that it is 5. So we have to add 1, 1 to this 8 to get the final answer. The answer will be obviously 11.19. Let us write the answer. Therefore, square root of 125.1229 is equal to 11.19 approximately. This becomes our answer. So now we know that how to find the square root of any number. Any number. It may contain digits on the left hand side of the decimal point. It may contain digits on the right hand side of the decimal point. Hardly matters because we know how to deal with these numbers, decimal numbers, and how to find the square root of any decimal number by the long division method. So students, this brings us to the end of this session. Thank you for listening.